All right, cool. Let's just start. I don't have clicker, unfortunately. Yes, I should have done it before. All right. We're gonna talk today about design at the front end meetup. But the reason we want to do that is mostly because I wanted to first ask you if you've been into this situation before. So please raise your hand if you've been in this situation where you've been working on the project for quite some time, and then for some reason the project, they had to shut it down, they had to cancel it, and it never been released. So who was in this situation before? Okay, I see hands. Great. And let me put it another way. So let's say I'm working on this npm library, and for some reason, I mean, it's just the cutting edge technology. It's the best library I've ever created. I published it on npm, and then for some reason no one uses it. Who've been in this situation before? Yeah. And this is, I'm not here to blame anyone. I'm not here to like tell that this is wrong. I'm just saying that this is normal. This is common thing. And the reason it happens is because, well, projects fail. We all fail. Well, it's not just, libraries and companies fail. It's also like, everything fails. But if you look at I borrowed this from the startup world, by the way, and if you look at this, the reasons why something fails, something never sees the production, one of the reasons is poor marketing. Is like, let's say, for example, you don't have enough Twitter followers, there is not enough media coverage. Well, this might happen. Another reason might be this is not the right team. But if you're working alone, who cares? I mean, you're the best engineer here, you're the best creator. So maybe that's not the case. Third reason is like, maybe it's you run out of cash, and in case of the library, you just run out of energy. You don't have enough power to continue developing this. But then finally, I think the most important reason projects fail is because there's no real market need. And what I mean by that is that you're doing something that no one will ever use. So there's no need for that. No one will ever use this thing. And I think this thing is crucial here because this is what we're going to talk today about. And I feel like the explanation why something doesn't solve the problem is the answer is in design. And when I say design, I mean the design in the very foundational meaning, the design as the art of solving problems. So my journey here today is to show you and to actually try to answer a question: if design can make you a better software engineer, can make me a better software engineer. But before I start, I wanted to start with actually trying to understand what the design is. And let's go back to the history and let's explore the origins of design. And when people say design, like the word design, it's really hard to distinguish where it came from, but it is considered that design was developed with the birth of school of Bauhaus. And Bauhaus was the school where, Dutch and German artists, they met together and they created this cool school for art. And the role of this school was to actually, the mission was to explore multidisciplinary arts with code theory, with geometry, like basically trying to explain how good art is developed. But if you look at the very first arts of Bauhaus, it's more like an art, not the design. Of course, there are some shapes here in Paul Klee's diagram, but still, it's more like an art. And I also want to mention that most of this artwork was not available for the general audience. It was only available for people who had money. And in this sense, still Bauhaus is considered to be the home of what is later be called the product design. And by product design, we mean all this furniture, basically things that people use in their everyday life. But then World War II came, and the school was shut down by Nazis for political reasons. And all the artists, they had to move to different places, to US. But this is actually a good thing because they decided that they're going to spread the knowledge about the school all around the world. Then there was the war, and during the war, it was like the design was mostly intended to solve the problems of guns, war machines, whatever. But then after war, people started to realize that we have new materials, we have new technologies. Why don't just sell it to people, for buyers, someone who will actually buy it? And that's why there was a new role of design that is called that design is now a tool that will help you to attract customers to your product, that will make it more pleasant for buyers. And of course, in this post-war era, there was a lot of design born, and not just mention, all this, like, I think great design. Of course, Dieter Rams, who've been working for Brown, the Stasio lamp. But I also wanted to mention that the design was not only about things. It was also about, the style. And people started to realize that they also can make the style of the company more, pleasant for buyers. So that's how this corporate style was born, like this great IBM's corporate style, which is still present. And now that we know where design came from, I wanted to talk about the rules of design. So the question is, how can we actually use the rules or methods from design and then apply it in software engineering? And in order to do that, I wanted to quote Peter Dormer, and he said that it was actually since the early 50s then when people decided that, well, we are big corporations. We can actually take design and form a set of rules, set of best practices out of design, and then apply it in order to make it more, faster, more, make more money, basically. But turns out there's actually no single principle. There's like many of them. And I came across this website called principles.design, which is basically a database of 4 design principles that you can use. And there's just like tons of them. But today we are just going to talk about some of them, which I think are foundational for industrial design and user experience. And I want to start with this principle. The first principle is the visibility principle. And what this principle states is that the more visible functions of the product are, the more likely the user will use them. And this makes us leaves us with another conclusion, that you have to prioritize what you're building, because basically prioritize function of your product. And let's see on an example. So this is actually a retro Panasonic IQ tape recorder. This version of the left is basically the older version, I presume. And this is like the more modern one. I guess the design is still different, but here the visibility principle is applied with the recording button. So basically all the buttons here, they are visible, but the recording button is the more like the primary one. So because it is a tape recorder, and the primary goal of this tool is to record voice. So that's why they probably thought that, well, this is not a good design. Maybe we can improve it and make this recording button more visible. So this is how visibility principle applied in product design. But now if we come to the code, and let's say we have this function that we use, and this is actually a real function that I found on one of the projects I'm working on. And so I think it was written by someone, and basically what it did is this function takes a user, cancels his active subscription, sends a confirmation email, and then there's also a third flag called test mode, which can be used in tests. So like if you don't want a real email to be sent, you just pass through there and everything will be just mocked. Well, this is probably not the best design, so let's think about how we can improve that. And basically, if we apply the visibility principle here, we can say that, well, the user is the primary thing here. So user is the main thing that is required here. And well, obviously, what we can do is we could make these parameters optional, right? Using this tool from the language we use. But this might not be the best solution. And then we just apply the common pattern that probably available in all of modern languages, which is like an object with options. And basically, what it does is it's an optional object, and it can control additional functions. So the cool thing about this tool now is that you only can use the function without any additional things. You cannot just pass user and it will still do the primary goal. And I also wanted to mention that in some languages there is also support of keyword arguments. Maybe it will land in JavaScript soon, but it's just a language thing, but basically it does it even simpler. Now let's move on to another, like a next principle. The next principle is called the principle of constraints. And basically what it means is that you can artificially reduce the complexity of your tool, and in some cases it can make the tool easier to use. So I have prepared one example for you today. So this is what I found in the wild. I don't know if it works. Yes. So this is a lock from the door I found in Sweden. So Swedes are really obsessed with doors. They really love building doors, all sorts of, like, you know, smart opening doors. They love that. And this is like a cool lock. And why is that? First of all, were you able to catch the code? Oh, it's here. All right. Didn't work. All right. So what's cool about this door is that it only has 4 digits, right? And from the engineering perspective, it doesn't, you know, it doesn't seem really secure. It's only like 4 and 4 and 256 combinations, which is like, I mean, I can like just brute force it maybe. But another interesting thing is that the code is actually 2244, and now it's, I mean, now it's even more insecure. But then when you understand the context of this door, it all makes sense because it's just the door to the public toilet in Sweden. So what I'm trying to say here is that sometimes you can reduce this complexity and it will make it easier because no one will like brute force the public toilet door. And this what can be applied in engineering as well. And I don't even think that we need an example here because basically the authorization or promo codes, if you ever developed something like that, the hashes, the alphabet, all that matters for the end user. Now, the next principle is called feedback and mapping principle. And basically what it says is you have to always make sure that there is a direct feedback between a control and the, you know, an effect, like what happens with this tool when you do something. And let's take a look at this, again, this tape recorder machine. And here we can see that the feedback principle is applied with the button itself. The button is like the best explanation of the feedback principle. It's a physical thing. You can press it, and you cannot longer press it when it's in, you know, pressed state. And the mapping is much more complicated, I think, is basically in this tool. It means that when you press play, the tape wheel starts to spin, and you see it immediately here because there is a window. And mapping sometimes is not required, but I feel like, and I believe that mapping and feedback these are principles that really affect the way we create things. That these are things that help us to be more creative and more confident with our tools. And here I'm going to post a link to this video at the end of the talk, but this is basically a guy who uses this retro tape recorder in order to simulate this echo chamber effect in voice. And the only reason it works is because this guy knows how to, like, what stands for the every control. He knows how this machine works, and this allows him to be more creative. And if we make a parallel with engineering, this is a slightly bit more complicated example. And let's say you're working on this part of the app, and basically you want to execute some actions once a specific element gets into a viewport. Of course, there are probably APIs for that, but let's say it's all like developed like as a single function, and like all the code that checks that the element is in viewport and does something. And if you ever try to do that, you know that it's like it's honestly like really hard thing to build because basically you get stuck into this, you know, endless loop of coding, opening the page, refreshing, scrolling. And this is not convenient. Of course, we all engineers know that this is not the way to do, right? And the reason, like one of the ways we can improve that is with proper decomposition. So basically getting rid of this big function and splitting into multiple smaller function, applying, like reducing side effects, applying test principles, testing it. So basically trying to reduce feedback loop. And Also, this leads us to another principle, which is also kind of correlated. This is the law of simplicity. And the law of simplicity says that when you save time, it actually feels like it's simple. And let's see how it works, actually. Well, if you take a look at the modern tools we all use, all the popular libraries and tools, they all follow this principle. What they try to do is they try to minimize time you spend with it. So that's why they all have this boilerplate commands. Let's for example, this npx command from npm that just allows you to run the command without actually installing it. All this done because they want to reduce the time you're waiting for this tool. And it just feels like it's simple. And when it's simple, it feels like it's a good design. Now, I also wanted to mention the affordance principle. And what the affordance principle states is that an affordance is a property of an object that allows you to understand how it works without actually knowing like what it is. And let's take a look at this Yamaha amplifier. And the good example of affordance is this control knob here. So there are multiple of them, but basically it just feels that when you just see this picture, you know that there's like this physical thing. You immediately want to just rotate it because it's a physical pattern that this tool follows. And sometimes it's not that clear. And I feel like it's worth mentioning that the affordance principle is not that you just see the object and you know exactly what it does. Sometimes it also requires a context. Let's take a look at this tool, for example. Who knows what it does, what this thing does? Okay, don't say it yet. Well, that's a lemon squeezer, right? And the reason the moment you realize that it's a lemon squeezer, you immediately know how to use it. You just put the lemon on top of it and you squeeze it, right? So this is an example of affordance principle that also requires some context. And I feel like if you want to compare it with engineering, I feel like this is the best example. And one of my favorite patterns in React, I know that probably none of you, all right, maybe all of you are familiar with React. But basically, when React Motion was released, there was this pattern that they used, this function as a prop, and it was new. Nobody kind of knew how it worked. But then, after some time, this pattern was adopted, and now you can see it everywhere. Like it's in the moment you see this code, you kind of know how it works. It's just a media query, and then there is a function. Then you can conditionally draw something. Yeah. Well, now that we talked about the design principles, basically we know how to compare if something has good or bad design. But now you probably wanted to ask, how do I actually make good design? How do I actually create things that people will use? And the answer to that is design process. And I feel like just like with design principles, they're just not a single one design process. There are multiple of design processes. And you can see it in companies and there are books about it. But I just wanted to look at this one. And if you take a look at this design process principle, you will see that basically has 5 steps. The first step is called empathy. Empathy is when you try to actually be your user, your customer. You try to understand how this person feels, what he believes in, and then as soon as you understand how this person behaves, you can distinguish a problem. And then when you have a problem, you as designer, you come up with a solution. And the solution might not be the best one. It might be just something that solves the problem, maybe not in the most elegant way. But then, after spending some time in this loop, you get an insight. An insight is something that tells you, oh, that's how you can solve it. And this is how the design is born. And then this leads to in better user experience. But now, I wanted to compare it to software engineering. But actually, then I realized that there's a real good example, all you know, and it's React. And there's a really good talk by Alexey about Facebook's product infrastructure, where he actually described how, as Facebook employee, he described how this library was born, how React was born. And basically, it also followed all these 5 steps. First of all, there was empathy, like the old developers. They know that it's hard to create user interfaces. And back in the day, it was really, I mean, it's because if you have a product with Facebook scale, it's hard to do complex things like, updating, do you remember Backbone? So yeah, it was kind of painful. And then they came up with a solution. They realized, and I also want to mention that Facebook initially, like kind of React predecessor, was PHP templates that they used on the backend. And then they came up with a solution, and solution was that basically UI is just a function of your data, of your state. But then this guy who created React, he tried to make this, well, he tried to do this, and then he realized that, well, it's hard to then mutate your view. And he came up with this really crazy idea that you always have to re-render everything. And when he mentioned it in Facebook, people stopped believing him. They just said, well, it's not going to work, never. And then, because that was the insight, he realized that you can actually reconcile, that you can diff. And this is how the good developer experience was born. This is how what we have now, the library. And I also wanted to mention that the good design process is all about stories. It's a story about users using your project, your tool, your library, API, whatever. And this is really interesting fact that, the storytelling is considered to be like the main point of design. It's all about telling stories. And I feel like this is probably the greatest example of storytelling in software engineering. So this is the Cucumber specification. This is actually a real test file. So you can take this txt file, load it into the spec runner, and you'll have specs. So these are real specifications that run on continuous integration. And I feel like this is the great example because it actually shows, it reads as a natural text. Well, some people believe it's not. Well, I'm not saying that you always should use it. I mean, this tool only works better when you have specific conditions, right? But still, I feel like this is a good example of storytelling. And then finally, this is one of the most interesting libraries probably. So this is the RubyGem, and it's called TimeCope. And what it does, it allows you to control the time in tests. So let's say you want to freeze the time or like, just travel into the future. So what's interesting about it is this tool tells a story, and the name based on the movie from 90s, and this is a sci-fi movie. They were inspired by this TimeCope character, so they built the entire API around that. So you have TimeCope, he can freeze the time, he can travel, go back, and this is quite interesting. I feel like this is like the culmination, the combination of design and engineering here. Well, now that we know these principles and design process, you probably wanted to ask, like, but I know all these things. Like, these are not the new stuff. I already knew about that. And the question is, so does it make us designers? Well, in order to answer this question, I wanted to quote Bruno Munari, who was a graphic designer, and he said that the designer is a planner with an aesthetic sense. So designer's job is to solve people's problems, and he doesn't fall back into some preconceptions. But if you actually change the word designer here with engineer, it also applies. And what I'm trying to say here is that there is no such thing as like design and engineering being two separate things. I feel like design and engineering, like engineering, and we engineers, we people who make software, our job is not about writing code. Our job is about creating tools and solving someone's problem. And in this sense, we also have to be responsible for it. So in this sense, we are also now kind of different from designers. So I guess that's it. But before I hop off, I wanted to also, I prepared a list of books that you might find interesting. And I wanted to emphasize this book on the left called Design for the Real World. This book is more about like the politics of design, how design, like if you wanted to learn about the responsibilities of design, please read this book. And then finally, you can find the design principles in this book with the teapot, quite popular one. There's also a book written by Dian Sujic, and I think he is the chairman of British Museum of Design. And this book actually tells the story of how this whole product design was born. Finally, there is like Laws of Simplicity book, which is not really a book about design. It's mostly a book about like applying simplicity principles. And I also wanted to encourage you to watch this talk by Mike Monteiro called How Designers Destroyed the World, because it will give you broad info about the responsibilities of design. So thank you. I hope you enjoyed this talk.
Thank you. Any questions?
Yeah, thanks a lot for the talk. I would love you to give an example, or maybe just tell us a little bit from your experience as a developer, how you actually implemented one of the principles, or maybe multiple of them in your developer's experience.
Yeah. Wow, this is a really personal one. I mean, I would probably spend hours talking about that because, well, my story, I didn't tell it in the talk because I decided to leave some room for design. And my story is that I started as an engineer, I studied math, I was into computer science, and then at some point I realized that I need to design something. And then my last, like, I think couple of jobs was about, design and engineering being always together. So I've always combined kind of, design, but in sense that I implemented, I designed the interface, and then I developed it. And this is what happened with the project that I'm currently leading development in. We started as like just 3 people. We built the MVP, and in a month it was like running, generating revenue. And I feel like this was a really valuable lesson for me because we didn't have enough resources, we didn't have enough time. So it was always about reducing complexity. So if you take a look at the very prototypes of the product, it was super simple, like just an interface, no landing page, just a registration, just payment. And I think I'm sorry, I think I got distracted, but to answer this, I feel like I think I have applied a lot of times this constraint principle, and it was always about not doing something, like not over-engineering, always trying to find the most dumb solution. And this is what works, especially if you work in startups. You have to do this because you don't have, resources, money, and time. And we did that a lot. I think I feel like there's still a possibility for we run a resume builder. People can sign up, pay, and download their PDF. But this is maybe not for the public. But there's still a way that you can obtain your free PDF without having premium. And it works because we wanted to test it. It's like simple. No one knows the URL, and it works. And this is the time. But probably at this point we have to get rid of it because now the company generates more. It's more like it's more like a security thing. And you just mentioned. Sorry.
And you just said that it's possible. So now we know.
Yeah, but you don't know.
So you have to get rid of this now.
Oh yeah. Yeah, but you don't know the URL, so it's fine.
Questions? It's all or not? Okay. Thank you, Alexey. Thank you for your travel from Moscow. Now break, 15 minutes.
Okay.